Good day, everyone. This time, I'm happy to discuss to you another topic for this week entitled Evaluating the Limits. Hope you will watch this video until the end. At the end of this lesson, you will be able to review different techniques in evaluating the limits and apply these techniques to evaluate the limits. Yes, this time I will discuss to you the different techniques in evaluating the limits. Evaluating limits make use of different techniques that will require us to refresh our knowledge on evaluating. These techniques will make evaluating limits faster. Here now are the different techniques in evaluating the limits. First, we have substitution. Second, factorization. Third, using conjugates. And fourth, algebraic manipulation. Okay, let me present to you first about substitution. This is the first thing you should always try when you evaluate the limits. Just plug the value of x into f of x. If you obtain a number that is not 0 over 0, Eureka! You found it. What I mean is that you're done. You have found the limit. Let us try this example. Find the limit of x cubed minus 5x plus 7 as x approaches 2. We will be using the substitution technique. If we will plug in the value to where our x approaches 2, we will have this. 2 cubed minus 5 times 2 plus 7. This is equal to 8, which comes from 2 cubed. Now I multiplied 2 3 times. Minus 5 times 2, that is 10, plus 7. Then when you operate these numbers, we will get 5. Therefore, the limit of x cubed minus 5x plus 7 as x approaches 2 is equal to 5. Another example. Find the limit of the natural logarithm of x over x as x approaches 1. Here, we will plug in the value of x and then it will become the limit of the natural logarithm of 1 over 1 as x approaches 1. Now, the natural logarithm of 1 is equal to 0. Then we will write 0 over 1 equals 0. Therefore, the limit of the natural logarithm of x over x as x approaches 1 is equal to 0. Let us move on to factorization technique. When is this factoring method possible? If each term in the polynomial shares a common factor or can be factored after checking that substitution is not possible, then factorization comes in. Let us try this example. Find the limit of x squared minus 4 over x minus 2 as x approaches 2. Frequently, when you try direct substitution by plugging in 2 to our x both in the numerator and the denominator, we will end up with 0 over 0, meaning it is indeterminate. We don't know yet what it is. This time, we will try another technique. If you notice that the given terms can be factored, go on. Now, we can see that the expression x squared minus 4 represents a difference of squares. This fits the form of a difference of two squares. So we will factor using that rule, meaning its factors are the product of sum and difference of bases. that is x plus 2 and x minus 2. Then we will copy x minus 2 as x approaches 2. Now, we can see common factor, which is x minus 2, in the numerator and denominator, meaning we can cancel the common factor and we have only x plus 2 left. To finish this, we will apply the substitution technique. We will plug 2 with x and now we get 4. Therefore, the limit of x squared minus 4 over x minus 2 as x approaches 2 is 4. Another example. Find the limit of x minus 3 over x squared minus 9 as x approaches 3. The same with our previous example, by inspection or by using direct substitution, we will end up with 0 over 0, meaning we are not done yet, because we can see that the given denominator is factorable. Obviously, x squared minus 9 represents a difference of squares. Do you know the factors of x squared minus 9? Yes, it fits the form of difference of two squares, or the factors are x plus 3 and x minus 3. Now, write the limit of x minus 3 over x plus 3 times x minus 3 as x approaches 3. Again, cancel the common factor and work on the remaining terms. We have 1 over x plus 3. Now, substitute 3 with x. We get 1 over 3 plus 3. And finally, we get 1/6. Therefore, the limit of x minus 3 over x squared minus 9 as x approaches 3 equals 1/6. This time, we will continue with the next technique using conjugates. By the way, let us review first what is conjugate. The conjugate is where we change the sign in the middle of two terms. We only use it in expression with two terms called binomials, and the conjugate needs to be multiplied to the numerator and denominator. Let's have this example. Find the limit of x minus 9 over square root of x minus 3 as x approaches 9. Again, the first thing we should do is to try substitution. Since this limit is in the form 0 over 0, it is indeterminate and tells us only that we have more work to do. So let's rationalize the denominator by using the usual approach of multiplying by its conjugate. It says that conjugate is where we change the sign in the middle of two terms. In other words, from square root of x minus 3, it will become square root of x plus 3. Then we get the product of the numerators divided by the product of denominators. So here, we get x minus 9, or quantity x minus 9, times the quantity of square root of x plus 3. When we use FOIL method to get the product of our denominators, we will end up with x minus 9. And this is equal to the limit of x minus 9, or quantity x minus 9, times the quantity of square root of x plus 3 all over quantity x minus 9. So, as we have noticed, we have common factor, which is x minus 9. So, we will going to cancel that. Then, what is left is square root of x plus 3. Since our x approaches 9, we will plug in the value of x to 9. So, we have here square root of 9 plus 3. So, the square root of 9 is 3. plus 3 equals 6. So therefore, the limit of x minus 9 all over the square root of x minus 3 as x approaches 9 is equal to 6. And finally, the last technique that I'm going to teach you is by using algebraic manipulation. For example, find the limit of quantity h minus 5 squared minus 25 all over h as h approaches 0. Again, inspect nyo muna if 0 over 0 siya by using substitution technique. Since through inspection, we will arrive really with 0 over 0, then we need to continue on. Here, we will expand quantity h minus 5 squared using FOIL method. Then we will come up with h squared minus 10h plus 25 and copy minus 25. Since positive 25 minus 25 is 0, what is left is h squared minus 10h over h. Next, h squared minus 10h has a common factor, which is h. Therefore, we will going to factor out h. Then what is left in the parentheses is h minus 10 over h. Now, we can cancel h. Then what we have is h minus 10. Finally, we will plug the value of our h, which is 0, because our h approaches 0. And 0 minus 10 is equal to negative 10. Therefore, the limit of quantity h minus 5 squared minus 25 all over h as h approaches 0 is equal to negative 10. Okay? Okay, I posted some worksheets in our e-leads. Please practice those problems over and over again to master evaluating the limits. Please do not hesitate to message me in our group chat if you have clarifications. Thank you so much. Till next time. Bye.